This is Horan from the Information Engineering Department of the Chinese University of Hong Kong, and this is my final year project. In the beginning, I thought about artificial intelligence and Internet of Things as my topic, and I couldn't decide which one to choose, so I combined them. This thing here, intelligent object searching and recognizing robot, is a complete IoT system with artificial intelligence features. Its main functions are finding objects, recognizing objects, retrieving and analyzing data. It consists of three main parts. Part A, an Android app for centralized control and management. Part B, a smart car for object detection and path selection. And Part C, a TensorFlow image classification model to classify the image. And for hardware components, I use STM32 for the main board of my smart car, an ultrasonic sensor and infrared sensor for object detection method, and motors to move the smart car, and Bluetooth to enable communication between each parts. And for the image classification model, I use Raspberry Pi 3 and Android Things. Android Things is an IoT operating system developed by Google, and it was released this year. It can run IoT applications on small boards, but with Android environment. So I run Android Things on the Raspberry Pi, and I hold the image classification model on the Android Things. And finally, for Android app, I use the Android cell phone, nothing special. And development tools, I use CUHK for STM32 development, Android Studio for my Android app development, and of course Python and TensorFlow library for the image classification model. And the main system flow. The smart car will move around detecting objects. Once it finds something, it will stop in front of the object and pause several seconds to leave time for the Raspberry Pi to capture the image. And the Raspberry Pi will capture the image in front of it with a camera module and send the image to the TensorFlow classification model. And the TensorFlow model will recognize the image, get the result, and send the result to a TTL engine. A TTL engine is a text to sound converter which will convert the result to spoken English. And all these are operated on the Android Things operating system as a holder. And the final step, the image and the result will be sent to the cell phone and will shown on the Android app screen. And the Android app will also sync the image and the result to the database system connected with the app. And for methodologies, for obstacle detection, I use ultrasonic sensors. Ultrasonic sensors transmit sound waves and receive sound reflected from an object. When ultrasonic waves are incident on an object, diffuse reflection of energy takes place over a wide solid angle. So ultrasonic sensor is one of the best and simple method for obstacle detection. And for image classification, I use TensorFlow, and it's a CNN model, convolutional neural network, a multi-layer architecture consisting of alternating convolutions on nonlinearities followed by fully connected layers, leading into a softmax. And it was trained with TensorFlow CFAR100 dataset provided by TensorFlow, which is a dataset consisting of 100 different classes of common daily objects. And the softmax regression I used applies a softmax nonlinearity to the output of the network and calculates the cross-entropy between the normalized predictions and a one-hot encoding of the label. For regulation, we also apply the Euro weight decay losses to all learned variables. The objective function for the model is the sum of cross-entropy loss. And the final part, for Android app, I use Bluetooth to enable communication between all the three parts, and a panel on the app to control the robot body and monitor every component condition. and the display interface to retrieve the image captured by the Raspberry Pi, and at the same time get the result and send these results to the cloud. And for the other half of my project, I will do data analysis on the database system on the cloud using different methods, for example, like data mining. And this is my first part of my FYP project.